this short video series I'll be talking about oil pressure and everything that's involved with it. There's been a lot of debate and talk about oil pressures, oil viscosity, and all that kind of stuff, and nothing really conclusive, and people often neglect the various other factors that are involved. And there's a lot of other factors that are involved. So there's I'd probably start off with a common myth that's out there that thicker oil is always better, and when people get an old car, a classic car, they talk to somebody else, and some old timer that says, "Oh, you got to put thicker oil in it," and because it's smoking. So as soon as they see smoke, and they assume, "Oh, you have to switch to thicker oil," and that is wrong. That's not necessarily the case. For you to understand exactly which oil to use, basically what I'm trying to accomplish here is to figure out exactly which oil to use, and how to know it's the correct. And usually that might just be a simple answer. You just go with what the manufacturer tells you to use. But over time, if an engine starts to wear out a bit more, you generally have. It is indeed correct that you sort of have to switch to thicker oil after maybe 400,000 kilometers or so on the engine. Once again, you don't really know exactly at which point, but the idea is that as clearances, as the metal sort of wears out over time, which ideally it shouldn't, right? But the idea is that people have that the metal wears out, and the width, the distance between them, the two metal surfaces, be it cast iron, from a cylinder block, from a cylinder wall, and a piston, as that distance increases, so you also need thicker oil, because that's what thicker oil does. It fills in that greater distance. But more specifically, things also get a little bit tricky when you've rebuilt an engine, which is what I've done. So again, people are saying you need thinner oil for a newly rebuilt engine, but there's a lot of things that are involved here, and I think I said it already. But one of the first dilemmas that I faced is that thicker oil protects better because it keeps the two surfaces, the two frictional surfaces, farther apart. That's indeed sort of correct. And if you have too thin of an oil, then that means that distance is smaller, and which could lead to them actually rubbing against each other at some point and then wearing out. Again, the whole idea about oil is to separate two metal surfaces by a liquid. That's all the oil is doing. If you have friction between two metals that are dry, they're going to wear out immediately, right away. If you put oil or some other, you could, in theory, use some other liquid, any other liquid surface there that separates them, that they're not actually physically touching each other anymore, but you still have something to fill in that space. So with a newly rebuilt engine, there's a lot of initial friction from the rings, however, and I have to say this because I sort of hear people talking about rod bearings and main bearings wearing out, and that's not true. They're not supposed to wear out at all. I've come to realize that there's no really, how can I put it? There isn't a mid term. There isn't a mid, something between there. It either wears out or it doesn't. Obviously that's true to a certain extent, but what I'm saying is, it's a bit hard to explain, but you can't really have, as soon as an engine starts wearing out, as soon as you start getting metal to metal surface contact, it's going to wear out. There's no half wearing out. It either wears out or it doesn't. But what happens is, over time, thousands and thousands of kilometers, you start to get dirt and junk and bits and chunks of metal going into the engine. And you have to think, you have to keep in mind that the engine is vibrating. It's constantly vibrating, it's dealing with explosions, right? So you have those two surfaces there, and you think that they're, the engine is turning around circular perfectly, but you have, especially on the connecting rods, the rods are slamming against the crankshaft, and they're therefore trying to squash that oil out of there. If that oil is too thin, then it will get squashed out of there, and that journal or that connecting rod will hit the crankshaft and increase the friction there. But on the other hand, if it's too thick, then that thick oil will not be able to get in between the walls, in between the two, in between the surfaces. So you have, it's all about balance. If you have an oil that's too thin, so imagine, take a given distance between two moving metal steel parts. If that distance is, let's enlarge it to help visualization. That distance is 10 centimeters, and our oil thickness is only 5 centimeters. And that means you're going to start to get rod knock, and you're not going to have enough protection there. Now, if that oil provides 15 centimeters, then it will not be able to fill in the space. So, once again, how do we know which oil to use and how to interpret the oil gauge? So in my car, like I said, it's a bit of a scientist's car. I've got a vacuum gauge, I've got two temperature gauges for the coolant, one on the engine block, the other one is actually a bulb inside the coolant, so it measures the coolant. The other one is outside, it's that barbecue gauge that I've shown you on another video. And I've got two oil pressure gauges, and how do you interpret that information? So at one point, previously I put in the thickest oil I could find, which was like 30, I think it was a 15W60 or something like that. And the engine started to use up a lot of oil, and it ran bad. It was loud, right? So that's one of the first signs to watch out for. The more noisy the engine is, that means the more friction you're getting. If the engine is running really quietly, then that's really good. That's a good sign. So if you switch to some other oil and the engine is a bit more noisy, then that's probably not good. And the other thing that really got me is that the manual recommends a few different. If you're using something close to what's recommended, it's not going to make a hell of a lot of a difference. So for example, if you're using 20W30 oil instead of 15W30 oil, that's probably not too bad. But once again, with a rebuilt engine, there's a lot of things that go into there. And if it's an old engine, then it most likely is using up or consuming oil for different reasons. The only thing that could cause oil consumption on the engine, apart from a leak, is the piston rings, or the pistons themselves. So what happens is, there's actually too much oil going into the explosions. It's mixing in with the gasoline and being burnt. So that's why you get the smoke. There's always a little bit of oil that gets burnt, right? But that's the only thing that really causes oil consumption in that case. From the piston rings. However, the valves can also cause oil consumption, excessive oil consumption on the engine. So the valves are connected. They come into contact with the with the cylinder walls, right? They come into contact in the explosion chamber inside the engine. So if oil, and there's oil around the valves themselves. So when that oil, if the clearances and especially the seals are bad, and when the engine sucks air in, it actually sucks in oil past through the valves, through the sides of the valves into the engine, and that's that's not necessarily corrected by switching to thicker oil. So you could have too thick. You add thicker oil and it maybe helps a bit with the oil consumption on through the valves or the valve seals, but then it's too much for the pistons or the piston rings. So I try to stay away from those easy fixes, and in most cases, oil thickness, you should indeed go with what's recommended by the manufacturer. And in most cases, switching to another oil will not fix your problem because of those things just discussed. The clearances on an engine crankshaft and an engine bearing are very, very, very small. They're thousandths of an inch, hundredths of a millimeter, so they're very small. As soon as that wears out, then you switch to thicker oil, you've already lost the bearing, the protective part on the bearing surface. So remember, the bearings aren't made of steel on the on the actual part where they come into contact with the crankshaft. They're made of some soft metal mixes of copper, aluminum, babbitt. They're soft, right? They're designed to be so that any junk, any bits of debris that they embed, they sink into the that soft metal instead of just perpetually circulating around. It would be interesting to have an engine with stainless steel or some other hard metal bearings someday, but I've never heard of such a thing. So as soon as that engine wears out, you think you lose too much oil pressure. That means it's time for a new engine. It's time for an engine rebuild. You could try a different oil. I mean, if it comes to that point, then you've got nothing really to lose with thicker oil. But it's usually not. It usually won't change anything. But moving on. So how do I actually interpret the reading from my pressure gauge? So obviously, first of all, you have to know if it's accurate or not. You have to get a gauge that's close to the ranges of the pressures you're expecting. So in my case, engine operating pressure, according to the manual, at operating temperature is at about 12 psi. So that's kind of low, and at first that sort of scared me because I didn't know much about the car and I didn't read the manual, and that's really low for most cars. Most cars operate at 40 psi or higher. So a 1947 DeSoto, for example, idled with a pressure reading of 40 psi. But that's way too high for the Rambler American, for example. Right, 1963 Rambler American. So in terms of a gauge, you need something that's close to that. Currently I'm getting 60 psi when the engine is cold. So when I first start up the engine, I'm getting 60 psi. We'll get to that in a second. But that's probably way too high for what I need. So the second thing that's often overlooked when talking about oil is the oil temperature itself. So in my case, when the engine is cold, as soon as I turn it on, the oil pressure goes to 60 psi. And then maybe 5 minutes later, when the engine is up to normal operating temperature, that pressure drops to about 12 or 10 psi on the gauge. And again, there's not many gauges out there that are accurate to within 2 psi. So if it's on the 10 psi mark, that's probably good. But one of the things that really tells me that the engine is really in good condition is that as soon as I hit the gas, or I start to increase the gas, automatically the oil pressure also increases. If your engine is bad, then you increase the oil pressure. You increase the RPMs, the rotations on the engine, and it doesn't really increase the pressure. So basically what happens is the more pressure you get, the more pressure, the more it leaks out. So if that's not happening, if you're hitting the gas and the gauge is going up, that's probably the best sign, the way I see it, the best sign of interpreting if the engine is in good condition. So a pressure gauge, an oil pressure gauge is, in my opinion, a very, very good way of diagnosing an engine. So I sort of see gauges as like a doctor's tool, How do the way a doctor can read, understand what the patient has. So I like to think of these things as an engine doctor. So speaking of temperature, what happens is as the oil gets cold, it gets very, very thick, it gets more viscous. And as the temperature of the engine increases, it becomes more liquidy, more like water. So, and especially in some European cars that use something ridiculous like 0W15, which is an oil that's like water. If you've ever done an oil change on one of those cars, after the engine is hot, which is the proper way to do it, you open that drain plug and the oil is like water. It's extremely thin. It comes out like coffee. On other vehicles, especially older vehicles, oils were supposed to be thicker. And once again, the way I see it is thicker oils means, just for you to understand, just drop a drop of thin oil, or just drop a drop of oil and then drop a drop of water on a table. What happens is the water really flattens out, but the oil, especially a thick oil like something like 30W50 or something like that, especially when it's cold, it'll stay in a big lump, and you can actually measure the height of that lump of oil, right? And so that's what I mean. That's a good measurement for viscosity. And as temperature increases, that thickness decreases. So a thing that people often overlook is the operating temperature of the engine, which is notably determined by the radiator and the thermostat. So on the case of the 1963 Rambler American, the manual actually lists 3 different temperatures for thermostats. There's a low temperature, 165 Fahrenheit. There's an 180 Fahrenheit. And there's 195 Fahrenheit thermostat. And by changing those thermostats, it will affect the temperature of the oil, the temperature of the engine, and therefore the temperature of the oil, and therefore the pressure of the oil gauge. That being said, you also have to keep in mind that a good part of heat lost by the engine is lost by the oil. The oil does a huge significantly huge amount of cooling of the engine. Right, so if the engine is hotter, then the oil will also be hotter and therefore thinner. So if you think maybe that you're using a certain oil, maybe the correct oil determined by the manufacturer, but the pressure is too high and the engine is not running as nice as it should, you could have the wrong thermostat in. Now, which was the case in my case. But I'd still like to do an experiment, and that's what I'm going to do in the next set of videos. I'm going to change the thermostats as well as try measuring. I'm going to measure the oil pressure with two different viscosities of oil. Alright, so that's one of the items. And the other really important item that people overlook is idle, or RPMs. So the manual will list a certain number at a certain RPM. As RPMs increase, rotations per minute increase, oil pressure should increase. So you have to know if your engine is running at the correct RPMs. So you could have, back in the day, some people were really obsessed with economy, and they're trying to be cheap. So they turned the engine idle to as low as they possibly could, and constantly that engine would sound like it was dying, but it was probably actually dying, if you get the pun. And if you have too low of an RPM, then the engine might not actually be getting enough lubrication. So you think, well, high RPMs damage an engine. Well, not necessarily, because it sort of fixes itself. The higher the rotation, the higher the RPMs, the more oil is being pumped. So it sort of strangles itself out, sort of thing. So you have to know, just because you have to consider all of these things when you're trying to determine, interpret the oil pressure. Alright, so I think at this point we still have some time. We're going to do a famous viscosity test. Sort of. So right now it's very cold. It's below freezing temperature of water. I've got two different cans of oil here that I picked up. By the way, I wouldn't waste your time buying little jugs of oil. You're going to have to do oil changes anyway, so you might as well just get the big gallons and save some money and time there. As you can see, I had to break off some ice. What I'm thinking is that the oil that I'm using right now might be too thick for this temperature. And by the way, the temperature variation only occurs when the engine is cold. As soon as the engine reaches operating temperature, it's the same temperature regardless if it's in winter or if it's in summer. So that's because, once again, because of the thermostat. The thermostat will keep the engine running at that specified temperature. So if I have a 195 Fahrenheit thermostat, it will stay closed, it will stay off until it reaches 195 Fahrenheit. So if the engine is below that, it will ensure that the radiator is off, right? The thermostat is just a valve. It's a shut-off valve. It turns the radiator on or off. So it ensures that the radiator is off until the engine reaches the correct temperature. Once it reaches that temperature, then the thermostat opens, allowing coolant to go through the radiator and thereby cooling it. And then it keeps repeating that perpetually, thereby maintaining that temperature and that range there. I'm not sure what that range is, but it should be something very, very close, very precise, right? So as soon, this happens regardless if it's summer or winter. But when the engine is cold, there will be differences because the engine is much colder in winter than it is in summer. But once it gets to that temperature, then it stays the same. However, if your radiator is not so good, or something's not so, working great on your car, then in winter, it could just be working fine. The cooling system is just working fine, but then in summer, the radiator isn't being able to keep up with the cooling demands of the engine, and you could overheat the engine. But once again, that's got nothing to do with the oil itself. That's you have to have a problem with that. The idea is that with a good radiator, a good cooling system, regardless of how fast you're driving, you should be maintaining that operating temperature. And by the way, some people think that the faster you drive, the hotter the engine gets. That's not necessarily the case. The engine will get much hotter if it's just sitting idling, because while you're driving, moving the car, you're getting fresh air going through the radiator. But when the engine is stopped and you're just idling, the only thing cooling the car is the fan itself. So it's probably easier to overheat an engine. In many cases, easier to overheat an engine when it's idling instead of when it's driving fast. But once again, we don't really want to discuss those things, because ideally you want the correct thermostat for the correct correct car, and you want the correct size radiator. So what I'm going to do here is, number one on my test here is 15W40 engine oil, and it's actually for a diesel car, but if it's a classic car, you actually want to use oils designed for diesel cars, because they tend to come with more additives for reducing friction, right? And the other one is just a single grade 30 oil that I also have here. So the deal with the, I believe I explained this in another video already, but my expectation is, right now everything is cold. Everything's at the same temperature. The cold temperature on this single grade here is just as the name says, single grade. The idea is that it stays in that same viscosity range for that temperatures. But obviously, with higher heat, the viscosity will decrease. So I'm not exactly sure how they classify these things. But my expectation is that since this one, the other engine oil is 15W, which means viscosity index of 15 when it's cold, I'm expecting that at this cold temperature that I'm in now,